before. Then, if teacher gives you this test, it's multi-tube fermentation test.
This
For
water
detection, coli index and coli titer. For determine this, we take 3 probes of water, tap water for example, on 100 milliliters, 3 probes on 10 milliliters, and 3 probes
and 1
1 milliliters. Mix with Kessler media or lactose broth media. It's special media for cultivation group E. coli, bacteria group E. coli. We put a small cotton plug for registration gas formation. If formate a gas, it's put on the top. Then we mixed concentration media with water and cultivation 2 days, 37 centigrade. After this, we may registrate results. We try to find growth of bacteria, its stability, or gas formations, it's to during the growth and multiply bacteria. Cotton plug may be put on the top. Now we check. It may be clear, all cotton plug on the bottom, then it's all negative results. Then it means 0, all negative probes. In other, all clear on the bottom, all negative probes. And this
This goes there.
1 is positive, yes, 1 is positive, is stability. Then it means 1.
It's positive.
Then after this we look on this table. This table teacher gives you. It's 0 for probes 100 milliliters, 0 for 10 milliliters, and 1 positive probes for 1 milliliter. Then coli index 3, coli titer 333. Teacher may
I want to see the one that is positive because I didn't understand it.
It's not clear. Yes, stability. Can you?
The one that has what? The one that has to what's stability now?
And look on this. Compare.
This one there is cotton wool inside. This one there is no cotton.
Yes, this no, but it's can you say growth? It's not clear media.
Okay.
Like your particles inside.
Okay.
See, everything is now.
Yeah. So was it the cotton wool that
This one.
that formed that?
I forgot to put the cotton.
This one, there's
They
nothing.
forgot to put cotton.
This one, you get.
Yeah.
There's nothing in this
Forgot
one.
to put cotton.
But this one, there's particles.
It's not because of cotton wool. No.
Not because of
Yeah,
cotton.
it's not cotton wool.
Their particles say they are not particles.
Let me see which one is
After
positive.
consultation. They will take after consultation.
Okay.
Okay, then. Coli index 3, coli titer 333. You must know what is this and say for teacher. What is this coli index? What is this coli titer? What is this coli index?
Coli index is the
Amount of bacteria group E. coli.
1
1 liter
liter
of water. Coli titer, minimal amount of water in milliliters. In which we find 1 coli form. Okay, then. And we must put conclusion. We may use for drinking water, this water, or no. Then you must know this normal for drinking water. For drinking water, coli index must be less than 3. Coli titer more than 333. Then, if it's 3 and 333, we cannot use it as a drinking water. Is that clear? That's all. If you're all negative, then look at this. With 0, 0, it's less than 3, 343.
That's what for drinking.
Yes. The next method which help to detection of coli index and coli titer is membrane filtration test. It's a this petri dish. concentration?
Yes.
We put what? Filter paper, special filters in this. First, a water for these filters. Put in sterile condition these filters on endo media. It's special media for cultivation, bacteria group E. coli. On this media we made detection this group, bacteria group E. coli, because its formation a pink color colonias, lactose positive colonias, because it destroyed lactose. Other entities don't destroy that. From these filters, paper on this media, cultivation 37 centigrade 2 days. After this, account the number of colonias. If you know how many water we pass through this filter, we may count colony index and colony time. For example, teacher said for you, then first 100 milliliters of water through these filters. Then, and grows 3 colonias. You see, grows 3 colonias. 3. This time. We must count colony index in 1 liter, other words in 1000 milliliters. 3 on 1000 and divided on 10. Colony index 30. Is it clear? Or no?
No.
You see then from 100 milliliters, teacher said what milliliters pass through. All 3 colonies. Then from 100 we have 3 colonies. How many colonies, how many bacteria present in 1000 milliliters, in 1 liter, because it's called the index. We count if in 100 3 and in 1000 it's 30. Is it clear now? If you know, thank you. Then it's colony index. For colony type, if you know colony index, it always may count colony type. Colony type a minimal amount of water in which we may find 1 coliform with 1000 divided on 30. X 3 and 3. Or 100 divided on 3. It's the same result. May use this or this method.
That's called
It's
tighter.
Colony tighter. Can we use this water for drinking?
No.
No. Very big colony index, a very small colony tighter. Then we cannot use it. Is it clear? Definition: colony index, colony tighter, and normal for drinking water. The next, total microbial number. Other criteria which we use for determining drinking water is total microbial number. It's amount of all bacteria, mesophilic aerobes, facultative anaerobes, in 1 milliliter of water. For detection this, we add 1 milliliter of water and spread on the surface petri dish with NPA. Cultivation 1 day 37 centigrade and count colonies. Look attention, you must differentiate. It's a total microbial number of water, it's total microbial number of air. Can you see difference? It's usually same colonies, and this different colonies. It's from air. It may be sarcina, yeast, fungi, and other. Then, for this, you count colonies and say this is a total microbial number. Among true methods, we must usually 2 plates. 1 we spread 1 milliliter on the surface, and other, as described in your exercise book, we mixed for facultative anaerobes, we must mix this water 1 milliliter with media and put this, and it's solidified. And in the middle of media grows facultative anaerobes. After this, plus number of 1 colonies in 1 petri dish plus to other divided on 2 middle amount of.
Yes.
And this be total microbial number. It's more true. You may set about this. But on module control, usually you have 1 petri dish.
Okay.
You must know about normal. Total microbial number for drinking water must be less than 50. That's all. For air, it's a total microbial number of air. Sedimentation methods, gravity sedimentation methods, with task number 4. Yeah. Then, you said that it's a method of setting under gravity. For this, we try to detection total microbial number of air. Total microbial number of air is a mesophilic aerobe facultative anaerobes, other word all bacteria, in 1 cubic meter of air. For detection, we open petri dish on 5-10 minutes, wait when sedimentation from air bacteria, close after 5 minutes, put in thermostat 37 centigrade, 24 hours. 24 hours. Okay. And after incubation, we count number of colonies. All. Put in formula. You must know about this formula to write down in your this. Present reaction. And in A it's a number of colonies, count, and it's usually at results about usually 1,000. It's a normal for usual rooms until 2,000, because until about 4,000 is a normal for usual room. But if this for operating room, it's not normal. Total microbial number for operating room before operation must be less than 100. After operation, maybe about 1,000. In operating rooms must be absent Staphylococcus aureus and Enterobacteria, Candida, and other pathogenic bacteria. Non-pathogenic, yes, may be present, but not than more 100. Is it clear? Okay, now I bring other from other groups. The next. What next? Demonstration pathogenic factors of Staphylococcus aureus, yes? Number 5. Determine phenotypic expression of Staphylococcus aureus pathogenic factors by growing on special bacteriological media, blood agar, urine agar, and characterize them.
It's continuation.
It's usually a complex for demonstration pathogenic properties Staphylococcus aureus. It's a Staphylococcus aureus on blood agar. It's a special media for demonstration pathogenic properties. Then, if bacteria produce pathogenic enzymes hemolysis, near colonies we see a light area. Its result destroyed of red blood cells, erythrocytes. In vitro we see as a light area. In human body it's destroyed erythrocytes, it causes anemia. It's a aggressive pathogenic factors. Is it clear? Other yolk, salt, agar. It's a selected media, Staphylococcus. Salt, why salt? 10% of salt inhibit growth other bacteria, but not Staphylococcus, because Staphylococcus is halophytes. It survived in this condition and may multiply in this condition. Yolk, because in yolk present lecithins, and it's helped to demonstrate pathogenic properties, production, lecithinase. It's a pathogenic enzyme which destroys lecithins. And if bacteria produce this, we see a white area near yellow colonies, but near this a white area. Can you see?
Yeah.
Oh? Okay, then it's a pathogenic factor of invasive and aggressive because lecithins components of cell wall, and as a result, bacteria multiply in human body may destroy cells as a leukocyte, for example, and cause leukopenia, suppressed immune answer. That is aggressive factors. Is it clear? The next, it's a citrate plasm. In one test tube grows coagulase positive Staphylococcus aureus and produce enzymes coagulase. Another is absent. Yes, it's liquid citrate plasm. It's a pathogenic factor too, aggressive factor, because formation a plasma clot in place of multiplication Staphylococcus defines